class with Hindu University of America on history and method of Indian astronomy. Wow, another direction. History and methods of Indian astronomy from Sunday, July 14th to July 29th at 6 p.m. for 1.5 hour class. Those who are interested, please talk to Vijay Kaneji or go to hinduuniversityofamerica.org and go ahead and register yourself. So without further ado, let me bring Dr. Vedam. So please. And after this, when I come back, there is a special treat for everybody who's been attending. So I'll share that later.
Thank you, Sanjay ji. Namaste, everybody. So once again, before I talk, my thanks to all the elders here who have managed to make these talks possible, Devendra ji, Subhash Gupta ji, and others. So thank you for making these talks possible. So let me see this on. Yes, Om Shri Guru Pyo Namaha. Turn this on. So we are now in the third of our 4-talk series. In the first talk, we addressed some issues that are attacking our identity, right? There are so many attacks on the Hindu identity, and we try to enumerate who are these people, why are they doing that, and we identified 5 frameworks. Those frameworks are the colonial people who wanted to rule India. So they came with a certain bigoted narrative, trying to show Hindus as backward, primitive, superstitious, and the West as forward, progressive, technologically advanced. That's the kind of drishti they came with when they wrote our history. Then we had the missionaries who wanted to convert Indians to Christianity. So they translated Sanskrit literature in a certain way to try to show Hindus as backward, primitive, and so on. So we see the effect of that even today. The third framework were the Eurocentric people who wanted to address why are Sanskrit, Latin, and Greek related. In their narrations, it was because there were some people called Aryans who lived in Central Asia, and they came to India around 1500 BCE, and we are all Aryans and Dravidians according to them. A whole lot of bigoted narratives came. Since 1947, after Nehru became the prime minister, he brought about socialism in addition. And the socialist angle also corrupted our history tremendously because it views all of the past as primitive. In India, the past is Hinduism. So Hinduism is primitive. We must throw it out for progress. So progress will come if you throw it out, and then you can have a classless utopian society, according to them. So they brought about laws in the constitution, the way it is addressed in our education policy, and so on. The effects are there even today in the United States and other places. Then the fifth framework is the Marxist. After Indira Gandhi made a pact with the communists for political survival in 1972, the Marxists also came in the picture, and they rule it till the present day. So those are the frameworks imposed in India. We learned about that. So in the second talk, we addressed in deeper detail, who are we? What is our identity? Are we, as they say, are we Aryans, Dravidians, and tribals? Is the evidence there in genetics? Is the evidence there in archaeology? Is it there in astronomy, climatology? We examined a lot of fields, and we said, no, there's absolutely no evidence. As a scientist, I went about examining the evidence, and we came to that conclusion. Today's talk is in the third topic. I'm saying that if India is an ancient civilization, that was our conclusion after the first 2 talks, that India is a very ancient civilization. If we say that, we must show evidence of knowledge systems. You must show evidence of accumulation of knowledge over thousands and thousands of years. Do we have that evidence? Because they are coming and telling us that you are a young civilization. Everything you learned has from Babylon, from the Greeks, from the Egyptians. They all taught you, but you didn't do anything. As far as mathematics, as far as astronomy, medicine, they say everything came from outside. So in today's talk, I'm going to address this because I'm saying that it does a very big injustice to the Indian systems. So I have a lot of slides. I'm going to go at breakneck speed. So I beg your pardon before I start for doing that. I'd like to cover some ground over here. So ancient India implies vast accumulation of knowledge. So we go back to the roots of our knowledge system. The roots of our knowledge system can be seen in the Smriti and the Shruti literature, right? So in the Shruti is that which is heard. It is an oral tradition, right? So that is the oldest we have, the Vedas, Samhitas, Brahmanas, Aranyakas, Upanishads. These are some of the earliest literature we have in India. Then Smriti is that which is remembered. Like if it's written, something's written, I read it and the symbols make sense to my mind. So I remember what it is and says that. So we got the Vedangas, Itihasas, texts on Dharma, Artha, Kama, Moksha, Puranas, Kavyas, Bhashyas. So many things are there. Whenever we talk about knowledge systems, we must scientifically look, did we have an epistemology? Did we have a systematic way of studying and accumulating knowledge? And the answer is a resounding yes, we did have. And these are called our darshanas. We had many darshanas of philosophical schools. For example, Nyaya, one-line statement. Rishi Akshapada Gautama said, all knowledge is not intrinsically valid. Most knowledge is not valid unless proven. Truth exists whether we human beings know it or not. Profound statements, right? Very profound statements. Then if you go to yoga, Patanjali codified all these that we know, the Ashtanga Yoga, we know that. Then Rishi Kannada on Vaisheshika. It is the basis of our scientific world, perception and inference. That is a way to understand the phenomena we find in nature. We study it through perception and inference. Samkhya, Rishi Kapila, he said systematic enumeration and rational examination. For example, the tattvas. We have 24 tattvas that are coming out in Samkhya literature, right? So all those things are enumerations of reality as we see and trying to examine each of them. Rishi Kapila introduced that. Purva Mimamsa, Kumarila Bhatta, reflection, consideration, profound thought, investigation, examination. Vedanta, up to 10 schools are there, Advaita, Visheshadvaita, and so on. I just put Adi Shankara there. Then similarly, so many other works are there. Even today, as a scientist, if I'm doing some new work, if I want to write, let's say, some theorem or some such thing, I go to the library, university library, I see who has worked in this area before. Then I see that all these gentlemen, scientists have worked on this. I enumerate their works. I enumerate all that is known about the phenomena I want to study. I study their methods, a rational examination. Then I go through a process of profound thought. I sit in my office and I think about it right on the whiteboard. Maybe I discuss with some colleagues and suddenly I have an aha moment and I say, okay, I understand what this is all about. Then I go about my own thesis, right? So we are basically using the same methods of our rishis, even today when we do our science and so on. So we had a clear epistemology and we had a clearly understood means for accepting knowledge. Not all knowledge is intrinsically valid, right? So we need a pramana. What is the pramana with which we can accept something? So we had several of them, pratyaksha, anumana, or perception, inference, comparison, analogy, postulation, non-perception, negative proof, or shabda pramana, relying on word of experts. The various sampradayas in India only differed in what was exalted as the correct pramana and what was not. All the philosophical differences between Dvaita, Advaita, and everything can be reduced to precisely this: what is accepted and what is not accepted. By the time you come to Advaita, you can see it's accepting everything. Charvakas in India, they only said perception, otherwise doesn't matter. So they rejected the Vedas, everything, only in my experience matters. If you go to Buddhism, it is only perception and inference, nothing else matters. So like this, India had a very well-developed system of knowledge. And this I said in the first class, the first talk. I'm telling it again because it is so important. If you want to talk to an Abrahamic who wants to convert you, you ask one question: what is the goal of life in your way of thinking? In the Abrahamic way of life, they follow a divine dictated law. Somebody dictated the law to Muhammad in a cave, or Christ, he said, the only way to Father is through the Son, or something like that. And so their goal in life is to follow that saying. Whatever the teaching is, follow it strictly. You are a sheep, you follow the shepherd. That is a metaphor in Christianity, right? Or in Islam, submit to the will of Allah. Don't question. Questioning is blasphemy, your neck should be cut off, right? You don't do anything. You just blindly follow. Why? Because in the afterlife, you'll be admitted to heaven, Jannat. Everlasting fun over there. Otherwise, you'll go to hell. Everlasting punishment. You'll burn forever and ever and ever in hell. So that is their thinking. We as rational people should question these things, right? Because that is the basis of the Indian civilization, rationality. So in our system, we are seekers. Our goal in life is to dispel avidya, dispel the avidya about our existence. Whichever sampradaya you go, whether it's yoga that you're doing, whatever meditation, why are you doing that? To understand yourself, to take away this notion of ego that I have, this attachment to the world of objects, emotions, and thoughts that make me a multimillionaire. That's who I am. Or I'm a big scientist, or I'm a big doctor, and all this kind of ego that we have that tries to make us separate from Brahman. We are trying to erase the difference to make our awareness happen, right? So that is the whole point of Indian systems. Based on our karma phala, we might accomplish this knowledge, Brahma Vidya, either in this lifetime or across multiple lifetimes. That is what Bhagavan Krishna is promising us. To Arjuna, he says, doesn't matter if you don't accomplish your goals in this lifetime. He says, nobody who worked towards this kind of system is lost. He says, in the next birth, you'll be born in a good family, closer to a spiritual goal. So based on your karma phala, in our thinking, you'll be closer and closer to spiritual goal or further and further away based on our karma. So this is the goal in life as far as we are concerned. As far as Abrahamics are concerned, no science matters, no knowledge, nothing matters. Only follow divine law, blindly follow, blind faith. Whereas we are seekers. The younger people in this audience, please understand this and internalize this. One line statement, we are seekers, we are not followers, we are seekers, seekers of knowledge, seekers of everything. We use the pramanas, all the pramanas I talked about, we use that to dispel ignorance. If somebody makes a truth claim, we don't blindly take the truth claim. We will analyze it using perception, inference, samkhya, enumeration, rational examination. Then we'll say, your heaven does not make any sense to me, where does it exist? So we'll come about with these kind of statements, right? If you're a true Hindu, you'll understand that, you'll do these kind of things. Anyway, so some of you might wonder, where did these darshanas come from? If you listen to the Western people, they'll tell you that, oh, it is the philosophical tradition system we had in Greece, where the philosophers like Pythagoras, like Socrates, like other Plato, they had discussions. That is what is in Indian darshanas. Nonsense, utter nonsense. Where is the evidence? Samkhya is mentioned in Rig Veda. So Rishi Kapila has to be put along with Rig Veda. As ancient as Rig Veda is, Samkhya tradition is over there. Then if you look at Rishi Kannada and Vaisheshika, he's talking about Samkhya and Mimamsa, but he does not mention Buddhism. Therefore, the West said he should be put before Buddha to 600 BC. That's the way they placed him. But if you look at the Puranas, Buddha is dated to 800 BC in the Purana tradition. Why should I accept the Western dating? The Purana tradition is telling me that Buddha should be put to 1800 BCE. Therefore, Rishi Kannada is prior to 1800 BC. Then Jaimini is before Kannada and probably after Kapila. And Nyaya Sutras were used by Buddhists. Therefore, they're earlier than Buddha. So in a relative dating, Samkhya comes first, then Mimamsa, Vaisheshika, Nyaya, Buddha in 1800 BC. So this is how ancient your philosophical systems are. This is the evidence that you have how ancient the learning tradition in India is in a systematic way. If somebody tells you you're a young civilization without a history of knowledge building, this is what you tell them. We have got evidence of pretty deep understandings of epistemology, the methods of science, the methods of learning is very much over here. Then in Vaisheshika, we look at Pratyaksha, which is Rishi Kannada saying there are two kinds, external, internal. External is through our identifications of worldly sense objects, right? So with the touch, smell, taste, all these kind of things. We understand the world and phenomena through that. There is one more kind of understanding through the mind, and that is what he's saying internal. Anumana or inference is reaching new conclusion and truth from observations in previous truths by applying reason. What else is the scientific process? What else is the scientific process other than examining old truths and building new truths based upon that? So this is basically the scientific process that we have over here. Then I'm going to tell you about knowledge systems in other parts of the world, because we must do that. As scientists, we can't say Indians are this ancient, we were the best. What about other people? What about the Egyptians? What about the Mesopotamians? So if we look at Egypt, we see that Egypt had an early dynastic period. Let me hide this. Just give me 1 minute when I hide this. Okay, so they had an early dynastic period going back to almost 3000 BCE. Then Old Kingdom, Middle Kingdom, New Kingdom, going to these time frames. And they had some kind of, I don't believe too much in pyramidal structures, but anyway, they had some kind of a structure. Thank you. Yeah. So in Egypt, Their epistemology was religious entities are reference to abstract ideas, similar to Indian learning. You have all heard my talks and TED Talks, right? Where I say that Chandra married the 27 daughters of King Daksha. What is it referring to? Is it a stupid story? Or is it saying that the scientific fact is the moon traverses 13 and one-third degrees in a 24-hour period? Therefore, it goes to one nakshatra every day. It's encoding a scientific information in the form of a story. Egyptians had the same methodology where they were abstracting ideas with religious entities. Answers are within established religious tradition. They don't go outside a known thing. And writing is upheld, syncretism inclusive. This is what we find the Egyptian epistemology. In the Mesopotamians, we had several civilizations. This is the Persian Gulf, India somewhere over here, and Babylon is over here, and several civilizations came about in this area. So there are three preconceptions of theory: imagination, deductive logic, and observation. So they believe that phenomena in nature, we must first reduce it with our imagination, which is basically a hypothesis, our imagination, and then you observe it, and then you make some sense out of it. After we come to Neo-Babylon is 500 BCE. They also said the more mathematical your theory, the more rigorous it is. So these kind of ideas were upheld in the Mesopotamians. The Chinese learned almost everything from India. So evidence of that comes from around 350 BC of an epistemology in China. So they had self-awareness based on holistic understanding of the universe, not in isolation. And they thought unity of all cosmos, just like Advaita, that everything is Brahman, unity of all cosmos. They thought emotional aspect is also important. Heart, mind, crucial part of self-awareness. And knowledge and the means of knowledge is important part of human existence. And they had big three: Confucianism, Taoism, and Buddhism. I'm not going to read all these things, but from 350 BC onwards is evidence about China doing this. What about the Greeks? In the Greek tradition, the evidence of epistemology only comes from 550 BC or so on, from the time of Pythagoras, literally. It comes from there. But more so with Socrates, with Plato, and Aristotle. These are the big three of Greek philosophies. Now, Socrates did not leave much of writing behind, but his student was Plato. So Plato left a lot of writing about what his teacher, Socrates, said. So the three sources of knowledge, according to Plato: first, he says, knowledge obtained from senses, knowledge of objects, color, taste. This is not real knowledge. He says, knowledge through mind or wisdom is the highest degree of knowledge. Where did you hear this before? This is exactly Vaisheshika. This is exactly Vaisheshika, which I know the route. Democritus was a person who internalized Vaisheshika in his travels to India, and he popularized it over here. And that is how we find Vaisheshika being practiced in the Greek epistemology. So from that, I'm jumping now to astronomy in ancient India. So remember, when we are all about evidence-based, I cannot present to you whatever I like, right? There's got to be some evidence for these things. So where is the evidence for astronomy in India? We are finding some pretty ancient works. For example, Vedas, Brahmanas, they contain astronomical content. Puranas contain some content as metaphors. Then Siddhantas are astronomical works with mathematics in them. And we are finding an enormous number of Siddhantas in the Indian tradition. Everything I've shown and read over here, we don't have them anymore. These are lost. But the citations to them exist in later works. Therefore, we know they existed, but we don't know what they existed. In some places, we know we have brief ideas. Vishnu Dharmottara Purana talks about that. Varahamira in his Panchasiddhantika, he's talking a little bit about that. Aryabhatta is saying that everything I learned is there in Brahma Siddhanta, but we don't have Brahma Siddhanta. It's gone. Long back, it is gone. It is not the same as Brahmasputa Siddhanta who lived later. So anyway, there are a whole lot of them. Vedanga Jyotisha, dated to 1400 BC, Vritigarga, and the Saura, the Surya Siddhanta. Again, some more works that are lost over here. Then going on, we have Aryabhatta, we got Varahamira, Bhaskara the first, Brahmagupta, Vateshwara, Munjala, and there is Aryabhatta the second. Many works are there. Bhaskara the second, Parameshwara, Nilakanta Somayaji, Ganesha Daivagnya, Yashtadeva. Then all the way up to Odisha, which is Chandrasekhara Samanta, who lived in this time frame and to later time frames. So we have a continuous tradition of Indian astronomy. It is not as if it is in bits and pieces we copied from the Greeks here and all those kind of things. Clear citation trail is there. Everybody saying who they learned it from. Clear citation trail is there. Clear mathematical growth evidence is there. I'll talk if there's time. I'm going to tell you those things. And some selected astronomers, I just skip through these things. Everybody knows about Aryabhatta, who was in Kusumapura, somewhere near Bihar or West Bengal today. And in Aryabhatta, you find all these things on mathematics and astronomy. He's talked about place value system, implicit zero. He's talked about the value of pi, rotation of the Earth, eclipse calculations, epicycle model, the Kutuka algorithm. And all of you who are in high school here who hate things like this, right? Summation of series. 1 squared plus 2 squared to n squared, and what is the nth term of the series, and some things like that. You can thank Aryabhatta for that. So he's the one who invented all these series and gave the nth term of the series. So going on to Varahamihira, he's famous because of Pancha Siddhantika. It's a commentary, Bhashya, he wrote on Paita Maha Siddhanta, Brahma Siddhanta, in Vashishta Siddhanta, Romaka, Pulisa, and Suri Siddhanta. So some of these works don't exist anymore, right? But it's important that he wrote these commentaries. That's why we know they exist. And so we learned about that. And Brahmagupta, who lived in this time frame in Ujjain, so he studied the works of earlier people, and he wrote this work, Brahmasputa Siddhanta and Khanda Khadyaka. Why is this important? Very important because bin Qasim was an invader who came to Sindh, which is now in Pakistan, in 711 current era. When he invaded that area, he also kidnapped some Pandits from that area and took them to Baghdad. In Baghdad, they were forced to translate works like Surya Siddhanta, Brahmasputa Siddhanta, things like Shushruta Samhita into Persian and Arabic. That's how the Arabs learned about Indian sciences, and their own sciences came only then. And this knowledge is taken and injected into Spain. That is next talk. I'm going to talk to you about that. Anyway, it's important for these things. Rules for zero operation, positive numbers, negative numbers, interpolation. And this is a famous formula. Brahmagupta had solved this formula completely in this time frame. In 1700, the greatest European minds like Euler, like Leibniz, they had no clue how to solve this equation. Eventually, they solved it after many years of trying, but 1,000 years before, Brahmagupta gave not just a particular answer, but the general answer. Those of you who work with mathematics will know that the particular answer and generic general answer. He gets given the general answer. Bhaskara first, who lived in 600 current era, and Bhaskara second, who lived in Ujjain in this time frame. So they also had done enormous amounts of works. In Siddhanta Shiromani, Bhaskara II has elements of differential calculus. Our modern world works because we have differential calculus. Otherwise, you can't have automobiles, planes, nothing. So he had said at the highest point, instantaneous speed is zero. Those of you who are in high school, what do you do to find out the maximum point? You take d by dt, set it to zero, and solve the equation, right? So he had expressed this kind of an idea a pretty long time back. Madhava of Sangamagrama, almost nobody knows about him. One of the most famous astronomers in India who lived in Thrissur, Kerala, around 1400, 1300s, 1400s. So he's from the Kerala school of mathematics. All those infinite series that you're seeing there is attributed to this school. 200 years before Newton, our astronomers had already got this kind of mathematics, expansion of sine theta, cos theta, tan inverse theta, infinite series for these things. Very, very important. Later on, this became Newton series, Newton-Gregory series. Now people are recognizing that 200 years before that, we've already got this. But the name is not changed as yet. Going on, other phenomena that are observed, solar eclipse. We observed solar eclipses, right? Rig Veda itself talks about a solar eclipse. And Rishi Atri is attributed with observing a solar eclipse. Many people mock Indians because it says Rahu and Ketu are two demons associated with the solar eclipse. Who translated it this way? The missionaries. They wanted to show you as primitive and backward, right? So they said Indians believe there's a monster called Rahu who swallows the sun and Ketu and things of this nature. Most of us have internalized this nonsense and believe it. It required Aryabhatta to explain what this is. Aryabhatta said, if this is the plane of the sun is this ecliptic that is shown over here, ecliptic, plane of the sun. The plane of the moon, as it goes about the earth, it is offset by 5 degrees from the plane of the sun. So if an eclipse must happen, these nodes must coincide. On this side, a solar eclipse, this side, a lunar eclipse. He called this Rahu and this is Ketu. Aryabhatta, he gave formulas how to predict an eclipse, how long the eclipse will last, where will the shadow fall. All these kind of things, Aryabhatta has given formulas. Aryabhatta, he's that amazing. He was just about 25, 23 years old when he wrote all these kind of things. Anyway, so that is the bottom line. And Tilak is on record who's investigating the Rig Vedic verse. The Rig Vedic verse over here is talking about a Turiya Yantra in respect to Rishi Atri, who about 4000 BC has observed a total solar eclipse. He's asking, why are you immortalizing Atri? Every one of us sees eclipse. Recently, if you've been to Austin and other places, you'd have seen a total solar eclipse, right? Just in April or so. So why do you immortalize Atri? Well, in Rig Veda, it says Atri used a Turiya Yantra in order to understand the eclipse. And he's explaining Turiya Yantra is like a protractor. Protractors used to measure angles. So you use this particular quadrant to measure angles between celestial objects. And why is that angle important? If you know this geometry over here, that when the angle between the sun and moon come to zero, that's when you know an eclipse is going to happen. So if you can measure that angle, you know it's going to happen. So Atri knew the geometry, Atri knew the physics, Atri was able to measure it, he was able to predict the next Amavasya there is going to be a total eclipse. So that is why he's immortalized over here. Anyway, going on, Indians observed precession, which is a 25,700 year cycle where the axis of rotation of the Earth this slowly traces a path in the sky. So right now we are pointing at a polar star called Polaris, but then it will change in the sky. So in Surya Siddhanta, for example, we have this one. It is talking about the circle of nakshatras. It turns 600 times in the Chaturyuga. This is a mathematical formulation. Later on, I'll try to show you what it is. Indians observe transits. Transits are when planets like Mercury and Venus, they go across the face of the sun. In 2016, I took this picture. This is a picture that I took in KT, where the little dot that you see here, this is Mercury going across the face of the sun. Now, I had to use a solar filter in my telescope to do that. With the naked eye, you can't do it. Now, can you imagine our ancestors were able to, they call it a Grahayuti. They're able to do this, predict it, when it will happen. And if it did not happen at the correct time, they're able to modify the parameters of that model. Their model is not good enough. They'll modify that. In the West, only after Galileo got the telescope, Kepler got data, they were in a position to predict the transit of Venus. It's the first in the Western world, whereas there's routine knowledge in India earlier than that. So Mallikarjuna Suri from Andhra Pradesh, he's the one who said that it appears as dark objects. For example, this person, Kamalakara in Maharashtra, who says that they look like holes on the sun. And there's a correct observation. If you look at Mercury and they look like holes, how could he have seen it? I have no idea. But then he's on record saying these things. He didn't have a telescope, and he says these. They observed conjunctions when planets would come close together and so on. They observed lunar occultations when the moon would cover a nakshatra. For example, the love story of Rohini and Chandra is related to occultation. I have said that in my TEDx talks. They observed things of this nature. They observed comets. Comets are called Dhumaketu. They have got so many comets in our literature, including in Sangamira literature, in Tamil works, in many other works. We don't know what some of the earlier observations were because periodicity of comets is very great. But after 12th century, we can reliably say this comet is this is that, and so on. So in the last talk, we already saw the antiquity of Indian astronomy. Vedanga Jyotisha, we put it to 1400 BC. Dhruva story, 2800 BC. Shatapatha Brahmana, Kritika, 2982 BC. Kali Yuga clustering in Revati, 3102 BC. Aditi in Aitreya Brahmana, 6000 BC. Surya Siddhanta clustering in Mesha Rashi, 6779 BC. And Ashwini's heliacal rising winter solstice, 7200 BC. This is all things we did in the last talk, right? We saw how ancient Indian astronomy is. We have evidence that Indians had a well-developed calendar system. If you're talking about calendar, you're talking about a celestial calendar, you should be able to measure the nakshatras, the planets. Measuring implies that I have a coordinate system. I should be able to fix it to the coordinate system and so on. So I'll show you some of these things over here. We have traditionally used Panchanga. Panchanga is a 5-dimensional measure of time, right? So the Muhurta is a basic interval, 1/30th of a day or 48 minutes. We have the Nakshatra of the day, sidereal measurement, Tithi of the day, or the phase of the moon, Synodi. These are all the Tithis over here. Vara, weekday, Yoga, angle between sun and moon, and the Karana, Tithi by 2. So these are always known. We have weekdays. These are all the weekdays in Indian tradition. People ask, where did this come from? Did it come from the Greeks, Romans, or Europeans, and things of that nature? We have evidence in Aryabhatiya, we have evidence in Surya Siddhanta that is talking about the ordering of the planets, why it should be ordered in this way, and why these are the days of the week. In this short talk, I can't tell you that. We have solar months. We had lunar months in addition. We had 5,000 years of time constants in calendars. If you look at the mathematics, one muhurta is 48 minutes, 30 muhurtas is an ahoratram, which is a sidereal day of 24 hours. 30 ahoratrams is one masa, which is 30 tithis, nearly 29.5 days, the synodic month. 2 masas is one ritu or a season of 60 days. 3 ritus is one ayanam, Uttarayana, Dakshinayana, that ayanam of 180 days. 2 ayanams is one varsha, lunar calendar, 360 days. And you might say, hey, wait a minute, 360 days, didn't they know it's 365.24 days? Yes, they knew. They knew there's a difference between solar calendar and lunar calendar, and tremendous intellectual activity went into trying to reconcile the two. Earlier, they observed something called an Atiratra sacrifice. During that, they don't count time, that shortfall, they don't count the time. But then Atharva Veda is saying, the Rishi called Rohita, he created Adhika Masa. This is also there in Rig Veda. So Adhika Masa is a calculation that is done when you put an extra month. So you have a synchrony between solar and lunar calendar. If you average it to 3 years time frame, they'll come out to be the same. So the Rishi called Rohita is the one who got the mathematics to do that. And Atharva Veda immortalizes him for that. And we got eras. It's not enough to have a day of the week. It's not enough to have months. It's not enough to have years. You must also say how many years elapsed. And in the Indian tradition, we got many markers, the Kali Yuga, the Buddha Nirvana, Mahavira, many of them are there. Moving forward, we have cycles, Hindu cycle of time, enormous cycle. If you go to Srimad Bhagavatam, that is talking to you about some cycles of time, right? It is talking about the Chaturyuga, Satyuga, Treta, Dwapara, Kali Yuga in 4:3:2:1 ratio. The last one is Kali Yuga, which is 432,000 years. Multiply that by 2, you get Dwapara. Multiply that by 3, you get Treta. Multiply that by 4, you get Satya Yuga. Add them all, it comes to 4.32 million years. So this was the notion of time. And if you take several of them, it comes to a Mahayuga, and 14 of them Manvantara. That goes to, by the time you go to Kalpa, we have 4.32 billion years that are seen as one day of Brahma. And one night of Brahma is a similar time frame. And in the interim, there's a Sandhya period. And after the Sandhya period is over, there's Pralaya. Pralaya is a dissolution and a new universe has come up again. It is nice to see it correlated to the present unknown Big Bang expansion of the universe. We think we have 13.8 billion years in the current expansion. We also have notions of multiverse and all those kind of things. But the time frames we are talking about here comes pretty nicely close over here. Anyway, each Brahma lives for 100 years, and we have the 51st year of the current Brahma. We know that the celestial calendar that Indians had, that is not constant. Why is it not constant? Because when vernal equinox happens, New Year is always vernal equinox in India. When vernal equinox happened, they'll say that was a nakshatra at the vernal equinox point. But that is not going to be the same nakshatra over 1,000 years. Why? Because Earth is precessing. Because of precession, over 1,000 years' time, that nakshatra is going to change, which means our calendar will change. The question, do we have evidence that our calendar has changed? And yes, we have evidence of that. So we go to Surya Siddhanta, like I said, it's talking about this nakshatras circled 600 times in a Chaturyuga. He says it moves 27 degrees westwards, returns back. In other words, he's talking about a sine wave. From 0 to 27, back to 0, minus 27, back to 0. And this is going to happen 600 times. So if you take 4.32 million years divided by 600, you get 7,200 years per revolution. Or you could take 600 years, multiply by 27 degrees, multiply by 4 segments, convert it to minutes, multiply by 60, to seconds, multiplied by 60, divided by 3.42 million years, you get 54 arc seconds a year. This is outstanding. This is outstanding because if you extend your fist into the sky, an adult fist, not a child's fist, it's about 15 degrees. You're extending 15 degrees arc in the sky, okay? If you extend your pinky, there's approximately about 1 degree in the sky. We are not talking degrees. We are not talking minutes. We are talking arc seconds. And our scientists are able to make out that in 1 year, because of precision, my vernal equinox is moving by 54 arc seconds in a year. That is a precision that your ancestors got without telescopes and things of that nature. It's an outstanding number, if you ask me. And you must ask me the question, all right, what about other civilizations? Did they have an idea? And what do they have? If you look at Surya Siddhanta, is what I told you, 54 arc seconds. In Parashara Siddhanta, which is dated to 1400 BC by Professor Iyengar, the same figure comes. Vriddhigarga had a regression with 36 arc seconds in 500 BC. Hipparchus, the Greek, in 120 BC, repeated the same figure, 36 arc seconds. He seems to have copied it from Indians. In China, in 300 current era, the figure was 72 arc seconds, very much in error. Aryabhatta got it at 48 arc seconds, which is better than Surya Siddhanta, because the true figure is 50.2 arc seconds. And so on. As you can see, there is a tradition in India of refining this. By the time you come to Patani, Samanta, Chandrasekhar, he had got it to 49.1 arc seconds. This is truly amazing because he was an impoverished Brahmin who lived in Odisha near Puri, who did not have an English education. He learned entirely on Vedic education. He schooled himself through the books of Aryabhatta and things like that. And he found all the measurements are in error. And he understood because precision is happening. He made his own instruments using bamboo sticks and things like that. Using that naked eye observations, he was able to refine all the ancient works. And his figure of precision is 49.1. Truly an amazing figure. It is telling us how our ancient people did that. If you wonder, how did our ancestors do that? We must study the methods of Patani, Samanta Chandrasekhar, who lived in 1800. Those are the same methods our ancestors did, and they got this kind of precision. Anyway, Indians had a good idea of cardinal points of astronomy, the solstice equinox, reference planes, and all these things, which is setting the stage for measurements. Do we have evidence of measurements in India? 5,000 years of evidence is there. There is evidence from Harappa, water clocks were used. And if you go to Aryabhatta, it's talking about all these instruments. Varamira is even talking about graphical instruments, just like you do XY graphs in your high school. Varamira was doing things of that nature. Brahmagupta, more instruments, Lalla, Mahendra Suri, and others. For 5,000 years, they were using measurements. Why would you measure something if you did not have a model, if you did not have mathematics? So clearly, there were all of these things. So we had a coordinate system. I'm not going to talk to you about this, except this last one. Ecliptic coordinate is what our ancestors had. This is a coordinate system where the plane of the sun, where the sun appears to go around the earth, that is a cutting plane. It divides a globe into two parts. And they used, with that as a plane, if this is a star, they had two measurements that will tell you the position of the star with respect to reference meridian. Reference meridian went through Ujjain. That is a place where vernal equinox would happen at Ujjain. Vernal equinox keeps changing with time. Therefore, that reference point also changed with time. We have evidence that Mrigashirsha was at vernal equinox in 4000 BC, Rohini in 3000 BC, Kritika in 2300 BC. So as the reference point changed, our texts are talking about these reference points. The first of the nakshatras is talking about that. So clear evidence is there about all of these things. And there is evidence that Indians had epicycle model. I'm not going to talk to you about these things, but epicycle model was there. Even in the epicycle model, by the time we come to Nilakanta Somayaji, who lived in Kerala, in the Kerala School of Mathematics, he had a partial heliocentric model. In his model, if you look at the sun, Mercury goes around the sun, Venus goes around the sun, Mars, Jupiter, Saturn go around the sun, but sun and this ensemble of planets go around the earth. Moon also goes around the earth. So this is a partial heliocentric model which he had. 100 years, 200 years before Tycho Brahe. Tycho Brahe in the West used the same model. So he's known for this model rather than Nilakanta Somayaji. But we have evidence of his works, Tantra Sangramaha and other such works. We know that. This is a work by a scientist called Anil Narayanan, who lives in Washington, D.C. He wrote this paper showing the accuracy of the Greek model and the Indian model and epicycle model. And he shows that the Greek error, this dashed line, is so great as opposed to the Indian error, which is much, much smaller in different timelines for the epicycle. Why was this necessary? This was necessary because people said Aryabhatta copied from Ptolemy. So he said, in Ptolemy's time frame, 100 current era, I will simulate the epicycle model. I'll simulate the Aryabhatta's model. And he showed the error in the Indian model is much, much better. In fact, the colonial person called Brennand, he also said the Surya Siddhanta's solar epicycle model is best around 3500 BC. This is according to Brennand, who lived in 1800s in his work, Hindu Astronomy. And Anil Narayanan simulated that even beyond that, and he shows in 5000 BC, the sinusoid that is closest to x-axis, that is the smallest error. So this is fantastic. I don't even know what sense to make out of it. I can verify Anil Narayan's work. I can verify Surya Siddhanta's work. I can tell you these parameters are right. But what sense do we make in 5000 BC? Indians had an accurate model that is so great. It just blows the mind. So concluding remarks on this is that we have shown great history and antiquity of Indian astronomy. Mathematics, I've already talked to you, whether it's Baudhayana, Madhava, or Ramanujan, there's a connection between all of them. Whether it's a value of pi, whether it's a value of the series that we talked about, or infinite series of Ramanujan, or whether it is combinatorics. Today's digital world entirely works on binary truth tables, right? Many will be surprised if we say that this is already there in India, Pingala, Chandashastra, or if you go to Hemachandra in 1100 and so on. They already work with truth tables. For example, if you take a look at this, if you have G and L as two syllables, n equal to 1, n equal to 2, n equal to 3, these are already there in Pingala's works. If you go to Hemachandra Suri, he's talking about how to arrange short beat and long beat for n beats into something called the Hemachandra sequence, today known as Fibonacci sequence. So anyway, there's a lot to talk about, not enough time. Bottom line, Indians observed a phenomena. They try to imagine it with some mathematics, physics. They try to measure it and try to fit it to that model. If there was an error, they try to figure out why is that error there. They refine the model with innovations, and they continue to use it for prediction. This evidence is there all over the place. We have evidence that Indians use mathematics for a lot of fields, whether it's enumeration. Rig Veda is talking about mathematics, addition, multiplication, big numbers is there in Rig Veda. If you go to architecture, you're seeing geometry, right angle triangles, and Baudhayana Silva Sutra. If you go to commerce, arithmetic, algebra, solving equations, Arthashastra is talking about taxation and things like that. Bakshali manuscript is talking about that. If you go to modeling, trigonometry, spherical trigonometry, approximation, Surya Siddhanta, Aryabhatiya, advanced modeling, function approximation, polynomial series, infinite series, Madhava's works, Yukti Bhasha. So clear evidence is there. Our ancestors had strong mathematical growth all through the years. Whether it's in Harappa, life is pretty standard with standard bricks, standard weights, all these things in Harappa. In Harappa, we have scales. Just like today, we use a ruler to measure things in centimeters or inches. Harappa had these kind of scales. This is the Mohenjo-daro scale, Lothal scale, Kalibangan terracotta scale. In the Vedic mathematics itself, it's not Vedic math. In the Vedic era, in Rig Veda, we have a number, for example, 3339. But what is important about this number? It is mentioned as 3,339, clearly showing place value. Place value was an innovation in mathematics that is not available in any other culture, but Rig Veda is talking about place value. We also have Shukla Yajurveda, which is talking about powers, 10 power 5, 10 power 6, 10 power 12, and so on. And if you go to Taittiriya Samhita, Shatapatha Brahmana, various altars are constructed. These altars cannot be constructed if you don't have properties of geometry, right angle triangles, and so on. If you go to Sri Chakra, Sri Yantra, for example, 9 isosceles triangle encoding a lot of mathematics. This is a very interesting archaeological find. In Kalibangan, they found, ASI reported that these floorings, look at the floorings, just like your modern mosaic flooring, in Kalibangan, they had these patterns over there. When I saw the pattern, I said, wait a minute, this is a mathematical formula. And this mathematical formula turns out to be in Baudhayana Silva Sutra. How to construct a square using circles. This procedure is given in Silva Sutra. This pattern that you see is exactly the pattern that you see here. Kalibangan is 2800 BCE, whereas the Westerners put Baudhayana to 600 BCE. How is that possible? So, infinity. Atharva Veda talks about infinity. Everybody here knows the Purnamidam mantra. We probably say that Purnamidam, Purnam. We say this is from infinity, you take away infinity, it continues to be infinity. So understanding of infinity is there. The Jains had a notion about infinity in this direction, the real line, positive direction, negative direction, infinity across area in a rectangle, infinity across a cube or a sphere going in 3 dimensions. Many kinds of infinities are known in India. Baudhayana Silva Sutras, which I put at 2500 BC, thanks to Kalibangan. This is talking about geometric solution of algebraic problems. If you had an algebraic problem, you could solve it using geometry, according to Baudhayana's work. You can refer to the works of Seidenberg, who's a historian of mathematics, who's calling out the geometric tradition of algebra in India, basically from here. Apastamba Silva Sutra, he's giving triples. For example, Baudhayana used geometric proof. But Apastamba is giving numeric proof of right angle triangles. He's giving all these triples for the Mahavedi altar, solution of quadratic equations, linear simultaneous equations, and so on. Manava Sulba Sutra, he's providing not only that, he's saying certain numbers like 2, 61, there's no proper square root. In other words, these are irrational numbers. He's talking about that. He's also providing triples with fractional sides. These are right angle triangles with fractional sides. He's providing these things. And if you go to Katyayana, he's now got even more intricate mathematics. So a clear growth of mathematics, as you can see, at a time when they tell us that Aryans had not even come to India. We are seeing all these kind of works over here. And there are several others. I put question mark because these are Western dates. I don't believe any of these dates, whether it's Panini, Pingala, or Jain literature, or Kautilya, Arthashastra. A lot of mathematics comes in there. What about other civilizations? Did they have place value? Did they have zero? Did they have decimal point? Well, Babylonians had a place value, but no zero. Even today, when we look at the clock, right? I'm looking at the clock, my time is run out. But the point is hours, minutes, seconds. These are base 60 system, right? So we still use that. So Egypt had no place value, no zero. Greece had no place value, no zero. Old China, they did not have any of these things. Modern China, there's place value zero. Modern meaning Buddhist era onwards. In India, for a very old time, we got place value in zero. We know that. From the year 1 current era to 1500, clear evidence is there. Bakshali manuscript found in Peshawar in Pakistan during the British time. It was a set of palm leaves that contained intricate mathematics, okay? And they carbon dated it in Bodleian Library in Oxford just about 10 years ago. And they dated it to 220 current era. And this contains enormous amounts of mathematics. It contains evidence of zero. For example, over here, multiplying huge fractions like this fraction multiplied by this to produce this. It contains things like how to find the square root of a number through an iterative algorithm. It contains that. It contains equations, problems of money, problems of travelers, problems of different kinds of things, commerce. Remember, 200 current era is Indo-Roman trade. Indo-Roman trade is going on in Gujarat, all the way from Gujarat, all the way to the western coast of India, all the way up to Bengal, including Andhra and other places. Every place, if you don't know mathematics, you can't do commerce. How do you say the value of a gold coin from Greek drachma is the same as the Chinese gold coin? The weight is different. What is the value? If you don't know ratios, you're lost. So our Vaishyas were not idiots. They were utter geniuses in mathematics. They learned all these things and they were able to do all these fantastic mathematics. Evidence is there in Bakshali manuscript. Bakshali manuscript written by Pandit who says, I didn't invent all these things. I merely compiled the knowledge available here. He was commissioned by a Vaishya who wanted him to teach his son. It's like a guidebook. That's what Bakshali manuscript is. Anyway, going forward, let me skip all these things. We have evidence of evolution of Indian numbers from Brahmi to the temple at Gwalior. We're seeing the zero symbol all the way to Devanagiri today, which went to Arabs after Bin Qasim's invasion. And this is the way it was represented. That went in 15th century. In the 16th century in Europe, it became these numerals as we see. So Adam Rees was a German computer, not computer the way you know it today. He was a guy who used to do computations. Those days, they used Latin numerals. So all the merchants will come to these computers using Latin numerals and abacus. They'll try to figure out their accounts and all those kind of things. So he knew about Indian numbers thanks to earlier people, Leonardo, who wrote about it, thanks to other people wrote about it. So he said the Indian way of doing things is much superior to Latin way. And he wrote this book. When he wrote this book, the Gutenberg press was invented just a few years ago. So this book was printed. Overnight, it became a sensation in Europe. Overnight, Europe threw out the Latin way of doing it and started using Indian way of doing these numbers. That is what we are seeing in this lady of arithmetic. You see Hindu numerals on her skirt over here. So there's evidence of modeling for astronomy. For example, in Vedanga Jyotisha, Lagada is saying, apply the rule of 3 again and again. What is the rule of 3? High school algebra. A by B equal to C by X. X is the unknown. Cross multiply and get the value of X, right? He's saying apply this again and again, it will get an answer to this. And the application is, I'm seeing Mars is over here today. 1 month later, Mars is over there. I want to know 2 months later, where will Mars be? So the application's over here. Let the planet move delta S units time delta T. In time T, how many units does it move? Use this formula. But he's saying, don't stop with one answer, apply it again to the known result, apply it again to that known result. This is what engineers call iteration, an iterative linear motion. This is known in our ancient works. That is what they're saying. Also here, the high school kids may want to see if delta t limit goes to 0, you have elements of calculus. You have the d by dt only. So anyway, we have evidence that linear is not enough, because if you do linear motion in the sky is curved. There'll be errors. I can predict it for a year, but it will be in great error. So to account for that error, they try to get circular functions. People say, the Westerners say, Hipparchus is the father of trigonometry. They love self-exaltation. But what Ptolemy and he had were chord tables. This is not trigonometry. Trigonometry is right-angled triangles. Right-angled triangles is there in Surya Siddhanta. The Jya and the Kojya appear in Surya Siddhanta. And that's what we see. And there's evidence that Aryabhatta used linear interpolation. By the time you come to Brahmagupta, is using second-order interpolation. And by the time you come to Madhava, is using infinite series expansion. Clear understanding that linear is not enough. Models have to be better and better. And I'll skip all of these things. We're running out of time. And Yukti Bhasha, this is the Malayalam work in Kerala of Kerala School of Mathematics, accomplishments in mathematics and astronomy. This is currently being translated in European universities. In India, the effort has been there, but not to the extent we would like. Anyway, what we see, evidence is that from ancient times, don't see any of these timelines. All these timelines are wrong. We are seeing that in ancient time and in classical period, all these mathematicians thrived in northern India before the invasions. The last person you see here, Bhaskara, who lived in Ujjain, was in this time frame. After that is Gori and all those people have come to India, Delhi Sultanate and other things. Everything died in northern India. You don't find any scholarship there. All that scholarship has come to the south because Vijayanagar kingdom protected them. 300 years of Hindu prosperity in the south, thanks to Vijayanagar kingdom, all scholars went here. That's why you see Narayana Pandit, Madhava, Parameshwara, Nilakanta Somayaji, up to Kamalakara. After Kamalakara is the European period. Complete death of Indian knowledge. So just one graph shows you how Indian knowledge has thrived in a sense. So anyway, I have medical heritage. I'm not going to talk to you about medical heritage. I have a lot to tell you about here too, but time is finished. So I'll just, for example, these are instruments that Shushruta is describing in Shushruta Samhita. This is found in Takshila in an archaeological find dated to 600 BC. This is there in a Pakistan museum. Even today, you can go to Takshila Museum, you'll find it over there. Clear evidence that by 600 BC, the operations that Shushruta was saying were being carried out. So a lot is there to talk about this, but bottom line, there's enormous antiquity for Indian medical knowledge. The roots of our medical knowledge goes to Atharva Veda itself. The trio of medicine is Shushruta, Charaka, Vagbhata. I've not had the time, I apologize, but to talk to you about Ayurveda and about ancient Indian medicine. What have I done today? Today, I address the question, if India is an ancient civilization, we must have evidence of accumulation of knowledge. Towards that, I tried to show you knowledge from mathematics, from astronomy first. Then I went on to mathematics. I couldn't cover medicine. So 3 main classical things. Enormous knowledge is there. Not only enormous knowledge, but citation trial is there. Citation trial is there to show you how ancient these works are. There's an accumulation over time. That is what we're seeing. So it negates all the nonsense that has been thrust upon us by the Westerners. So in the first talk, I showed how Indian deep history is utterly wrong, and the agencies controlling our frameworks, our narration of history. In the second talk, I showed evidence to uphold the antiquity of the Indian civilization with multidisciplinary evidence showing there's no invasion or Aryan migration, all this nonsense, and how ancient the Indian civilization is. In today's talk, I've shown to you a well-developed epistemology showing great antiquity, well-developed mathematics, astronomy, and medicine. In the final talk, I'm going to talk to you about how Indian knowledge impacted the world. I'm going to show you that also. Most people have no idea about these things, but I'm going to show you about this too. So this is the 4th talk. And quickly, Vijay wanted me to talk about this. I also offer these things at Hindu University of America. There are 2 courses that I offer. This is not currently offered Reconstructing Hindu History, the Commissions and Omissions. Over 2 terms that talk about this. The upcoming course is History and Methods of Indian Astronomy. Anyway, with that, I think I've come to the end, and thank you very much for your patience and listening to me. Thank you.
I welcome you all to today's satsang. It's been very enlightening, right from 9:45 with Sandhya Havan, bhajans, and now Dr. Vedam talking about another aspect of true history of India. So I know people have joined us from YouTube. You're also equally welcome. And those of you who miss it, please go and watch it again on YouTube tomorrow. I see a lot of new faces, so I'm going to talk a little bit about Arya Samaj in a little bit. But we have a very special person attending today who worked with Dr. Vedam when he first started this search for true history of India. And she's now a second-year student in UT. Vrinda Vedam, his daughter. So people say there is a woman behind everybody's success. Well, guess what? There's a daughter behind his success. Anyway, moving forward, I told you we'll have a special treat for everybody. But before that, let me share with you those who are new or coming occasionally. We have yoga every Saturday and Sunday from 8 a.m. right here or in the school building. Our weekly satsang starts at 9:45 and goes till noon. We probably be 12:05 today with Havan, Bhajans, Pravachan, and Preeti Bhoj at noon. Our schools we run here go for 2.5 years to 12th grade. And this is a new session starts in August. So does the Vedic education. So the special treat is July 21st, which is after his fourth talk. He will conduct a Q&A session right here from 10:30 to 11:30. I'm so grateful, and we are so grateful. He has a flight to catch that afternoon, but he gives his 1 hour here before he goes to the flight. So thank you, Dr. Vedam. But a special request, please send your questions to info@aryasamajhouston.org, info@aryasamajhouston.org. And we shall collect all of them by 19th, so he at least gets Saturday at the 20th to collect the answers. I think having random questions here kind of disrupts the flow, but he's very capable of answering them. So that's not the reason, it's just to make it nice for everybody. Please send your questions. We already received 3 questions from one person who's been also very forceful in getting this happening, and this is a great session. So please do that. Let me talk to you about 2.5 years to 5th grade, our DAV Montessori Elementary School. Montessori clearly means we follow the Montessori education system, and that ends in 1st grade. Then we go to elementary school system, which is also accredited by TAPS, which is also following the state laws. So the students going to this school are second to nobody in other schools all over the country, all over Texas at least, but they are at least ahead of everybody else. Let me share you why. There isn't a school which won 3 private school inter-academic scholarship awards. 3 years in a row, 22, 23, and 24. So it's a great feather in their caps. And the main message is get those younger students here, not to be devoid of the education they get here. Beyond the education that I talked about, traditional program, Hindi as a second language, Vedic prayers and yoga is all taught to them. Imagine if you attended any of the schools and any of the programs for the schools, they recite the prayers, not just by memorizing, but also knowing the meaning. So that's a wonderful thing. And let's go ahead and get this gem used by everybody in Houston area. Then for the elder kids, starting from KG to 12th grade, which includes RA Yuva Mandal, we have two schools, one in person, VSS Houston, Vedic Sanskriti School Houston, and the other we call DAVSS for 30 years now. And the other is VSS Global, which we are trying to reach those students who are not present in Houston area or unable to come personally. And these both admissions are open on the davss.org/admission. Please share that, get the best of these. The adult education for Vedic education classes schedule will come out in August, but typically held Monday to Thursday. Various topics, including Sanskrit, Upanishad, Vedas, Gita, meditation, and so forth. So new series will be set up, and I'll be happy to share that with you. But for more information, you can always visit our webpage and Facebook page. Thank you so much. Let's rise for Aarti.
ओम जय जगदीश हरे स्वामी जय जगदीश हरे भक्त जनों के संकट दास जनों के संकट में दूर करे। ओम जय जगदीश हरे जो ध्यावे फल पावे दुख विनशे मन का स्वामी दुख विनशे मन का सुख संपत्ति घर आवे सुख संपत्ति घर आवे कष्ट मिटे तन का। ओम जय जगदीश हरे मात पिता तुम मेरे शरण गाऊं मैं किसकी स्वामी शरण गाऊं मैं किसकी तुम बिना दूजा प्रभु बिना और दूजा आस करूं मैं जिसकी। ओम जय जगदीश हरे तुम पूर्ण परमात्मा तुम अंतर्यामी स्वामी तुम अंतर्यामी पार ब्रह्म परमेश्वर पार ब्रह्म परमेश्वर तुम सबके स्वामी। ओम जय जगदीश हरे तुम करुणा के सागर तुम पालन करता स्वामी तुम पालन करता मैं सेवक तुम स्वामी मैं सेवक तुम स्वामी कृपा करो भरता। ओम जय जगदीश हरे तुम हो एक अगोचर सबके प्राणपति स्वामी सबके प्राणपति इस विद में दयामय इस विद में कृपामय ऐसी तो सुमति। ओम जय जगदीश हरे दीन बंधु दुख हरता तुम रक्षक मेरे, स्वामी तुम रक्षक मेरे, करुणा हाथ बढ़ाओ, अपनी शरण लगाओ, द्वार पढ़ू मैं तेरे, ओम जय जगदीश हरे, विषय विकार मिटाओ, पाप हरो देवा, स्वामी कष्ट हरो देवा, शरणागति बढ़ाओ, श्रद्धा प्रेम बढ़ाओ, संतन की सेवा, ओम जय जगदीश हरे, जय जगदीश हरे, स्वामी जय जगदीश हरे, भक्त जनों के संकट, दास जनों के संकट सर्वे दूर करे, ओम जय जगदीश हरे, ओम जय जगदीश हरे, ओम जय जगदीश हरे, सर्वे भवन्तु सुखिनः, सर्वे सन्तु निरामयाः, सर्वे भद्राणि पश्यन्तु, मा कश्चित् दुःखभाग् भवेत्, हे नाथ सब सुखी हो, कोई न हो दुखारी, सब हो निरोग भगवन, धन धान्य से भंडारी, सब भातृ भाव रे, सन्मार्ग के पथ को, दुखिया न कोई होवे, सृष्टि में प्राण धारे, दुखिया न कोई होवे, सृष्टि में प्राण धारे, ओम शांतिरंतरिक्षं शांति, पृथ्वी शांतिरापः शांतिरोषधयः शांतिः, वनस्पतयः शांतिर्विश्वे देवाः शांतिर्ब्रह्म शांतिः, सर्वं शांतिः शांतिरेव शांतिः, साम शांतिरेधि, ओ शांति शांति शांति। जो बोले सो अभय, मर्यादा पुरुषोत्तम श्री रामचंद्र जी की, योगेश्वर श्री कृष्ण जी की, महर्षि दयानंद जी की, ओम का झंडा, आर्य समाज, वेद की ज्योति, प्रणव ध्वनि, ओ भोजन मंत्र, ओम अन्नपते अन्नस्य नो देहनमीवस्य शुष्मिणाः, प्रदातारं तारिष ऊर्जं नोधे दुपदे चतुष्पदे, ओम शांति शांति शांति। शांति। सबको सादर अभिवादन हम सबकी ओर से।